Hi, we are Team Keen Bullfinch Steinmetz from Neuromatch Academy, Pod-009. My name is Angel Huang. Today, we will present our project on decoding movement from brain-wide signals. Brain areas are often studied for their specialized functions, for example, motor cortex in relation to movements. However, it remains unclear how much of the neural information is shared with other brain regions and if that information can predict behavior as well. So our main question is, what are the neural spectral features that predict behavior and how widespread are they in the brain? To answer this question, we worked on a rich data set collected by Steinmetz et al. We selected local field potential data from 11 representative brain regions and aimed to use this data to decode animals' movement, which is a left or right turn of a wheel after seeing the visual stimulus. Our preliminary results showed that the spectral features can be reduced with PCA without loss of inaccuracy of decoding of movement decisions. And the different brain areas share similar PCs that extract frequency band features. And at last, the movement decisions can be decoded from many different brain areas besides motor cortex.
Specifically, we approached this question by looking at the LFP and the corresponding power spectrograms between trials of left and right decisions. We noticed that the spectrograms look different in those conditions, and therefore we extracted features by dimensionality reduction and feature elimination. We then used those optimal features to decode the decision. We were able to accurately classify the decisions with only a few PCA components of the power spectrum, explaining less than 20% of the variance. The weights on these PCA components load on different frequencies at different times. Those patterns look very similar in different brain areas. This indicates that the information to decode movement is shared across the brain.
After doing PCs over the whole brain, we're curious to see how would area-specific PC look like. Will they share similar features? So we applied PCA on each brain region's power spectrum and verified that the top 10 PCs in each area explains more than 90% of the variance, indicating that they are good representations of the spectral features. Then we plotted PC weights on each frequency. We can see that the weights are picking up some of the frequency band features. Comparing it with a visual cortex, we see a very similar PC weight pattern. So how generalizable is this pattern across the whole brain? We plotted the first of 5 principal components on a 2D plane using t-SNE. This t-SNE plot reviewed distinct clusters of each principal component. Within the first PC cluster, we can see that it includes not only the cortical areas, but also thalamic areas and the hippocampal areas, indicating that the PC representation of the spectral features are widely shared among those regions.
We also found that the brain region's time window-specific brain power is informative for our classification task. Indeed, we use it as features for the classification together with a recursive feature elimination algorithm, and we found that if we consider the time window from the stimulus onset to the go cue, it will be the alpha band information, the one providing the best classification performance. And this alpha band information will be widespread across several cortical and subcortical regions, which are those marked in dark blue at the bottom. Instead, if we consider the last 100 milliseconds before the go cue, it will be the beta and gamma powers in the motor areas, the one providing the best classification performance.
In order to confirm whether the individual brain regions had any effects in classification performance, we compared the spectrogram feature in different classifiers, including logistic regression, LDA, QDA, and SVM. As you can see, using the spectrogram feature provides the accuracy better than using the spike data. Once again, movement decisions can be decoded from many brain regions besides the motor cortex. Our results show that the PCA can be applied to the spectrogram features without loss in the accuracy. In conclusion, in our study, many questions are answered clearly. However, we would like to explore in more details in our classification results about the precision of the decoding movement and the result can hold in other brain regions and atomize or not. Moreover, we are interested in decoding of the pre-stimulus activity and the trajectory of the PCs over time.
It is important to mention that we learned so much from each other along this experience. We are 4 individuals with very different academic and cultural backgrounds, and this diversity became an advantage when put together into the work we carry out during the project. We were constantly sharing programming tricks and different problem-solving strategies at this stage of the project, and surely this overall experience equipped us with some professional and soft skills that we will carry with us far beyond the NeuroMatch Academy. Finally, we would like to thank the Academy, our pod, our great TA, Catherine Overman, our mentors, Ella and Anne, for the guidance and support they provided us along the last 3 weeks.